Hi, folks. Welcome to the Routing Loop, our weekly show about all things networking on AWS. My name is Tom Adamski. I'm a principal solution architect focusing on networking, and I got a bunch of really cool guests today. It's a full house, so not very often there's 4 of us on the screen. We'll do a bit of an introduction, but we actually have a customer of us today. We have Molly from Best Buy. I'll probably leave him for last because we're going to leave best for last. So I'm going to start with introductions from the top. So Mandar, you want to do a quick intro? Tell us what you do and how long have you been with AWS?
Yeah, sure. Thanks, Tom. So my name is Mandar. I work as a senior networking specialist solution architect here at AWS. I'm based out of Seattle, and almost it's been like 6 years that I'm working for AWS. And I work with different divisions of the customers, like the retail, enterprise, DMX, and all that stuff. And I work with the Best Buy for this upcoming solution that we're gonna discuss for. But yeah, so happy to be involved here.
Very cool. Jason?
Yeah, thanks for having me. Jason Champ, Principal Solution Architect. Been at Amazon for 5.5 years, and of that, I've been supporting Best Buy as their primary solution architect for the last 4.5 years. So I got to know Mooley and the whole networking team and everyone at Best Buy and along their cloud journey. I'm based in Cleveland, Ohio. Really excited to spend some time with you today.
Awesome. And Molly, let's hear from you. Give us an introduction and how long have you been with Best Buy? And maybe you want to share a little bit about the project at high level. Because I didn't realize until we had a chat recently that Best Buy also has a health or healthcare arm, and that was very interesting to me. That use case is something that's super unique.
Sure. My name is Mauli Natarajan, staff network engineer, been with Best Buy for 5+ year, and primarily focuses on connectivity in data center and cloud and cross cloud and all those stuffs.
Cool. And then, do you want to talk a little bit about the project and the background of kind of how this all originated? How did you guys ended up going with Cloud WAN or were thinking about Cloud WAN? What was the starting use case?
Sure. So, as many of you know, Best Buy is known for its specialty electronic retailer, but lately we have been in health business as well. So we call Best Buy Health. The nature of the business is like we provide technology care to elderly people, senior citizens, care at home, hospital at home, and urgent response and those kind of services. And because of that nature of the business, the connectivity between an end user and the workload or the applications that support the nature of the business is very crucial, and it requires subsequent convergence or latency to provide a best user response.
Yeah, that's an interesting use case because I'm only familiar with Best Buy for the consumer electronics, but that use case is like a completely different ballgame, right? Because I'm
Right.
assuming the availability requirements and the connectivity requirements for the healthcare use case, they're a lot more critical than making sure the electronic store is connected.
Right.
Awesome. And it sounds like you also worked as part of the team. Was that a big team of network engineers involved in
Right.
setting this up, cloud
So
engineering?
with this particular architecture, I want to give shout out to my peer engineer and principal network engineer whose name is Joshua Hall. He was key on this, implementing the whole architecture. We worked together and built this. Um, yeah, maybe we can dive into the actual content.
Awesome. Yeah, so we'll do like a little bit of an experiment. I know only you've built a bunch of slides. We can go through them as well, but on the side, we're going to jump between the slides and some whiteboarding. So I'm going to try and whiteboard the use case that you have, and please correct me if I'm wrong as I'm going through it. But
Sure.
I'll pop your slides up, and you're good to go with kind of kicking things off and giving us a little bit of background. And then
Yeah.
for folks on the chat, feel free to drop in questions. We'll try and answer any questions you might have as we go along.
Sounds good. So in this sequence of slides, we are going to talk about the overall architecture review and the code design principles and what was the integration strategy and what was the low-level routing and connectivity strategy between the SD-WAN components and Cloud WAN constructs and all those stuff. And what is unique on this architecture and what was the benefit that we reaped out of this? So we'll go in deep in upcoming slides.
Awesome.
So, as a key architecture overview, we implemented an approach where both SD-WAN VMs share single connect attachment, and the connectivity between the VMs and the Cloud WAN is established via tunnelless connect peers. This is new on Cloud WAN, and back in transit gateway world, there is no tunnelless concept, and we will talk more about what is the actual benefit of the tunnelless thing. And in this particular architecture, one connect attachment will have two connect peers, and each connect peer is dedicated to one VM, and each VM will have a dedicated layer 3 path, an active path between the VM and the Cloud WAN core network edge. And
Got it.
from a SD-WAN VPC design perspective, we span this VPC across two availability zones for resiliency purpose, and one VM is hosted in per availability zone. And each VM will have dual interfaces, so one for the workload connectivity towards Cloud WAN, and another one is towards internet, which will have both private and public elastic IP addresses. So both will have independent paths to Cloud WAN, which is the key differentiator in this architecture.
Okay, so maybe we can take this moment to just whiteboard just the initial scenario,
Right.
and so get some kind of visual for folks to see what's going on.
Yep.
While we draw it, I actually have a question for you on, have you guys already been on Transit Gateway, and this was more of a, we know we have Transit Gateway, we're moving to Cloud WAN, or was this a completely greenfield use case and you were starting from scratch and you decided to go with Cloud WAN?
Sounds good. So our retail side of the business, we started with the transit gateway approach. Back then, Cloud WAN was not enough matured to adapt. Things were keep evolving, and transit gateway was a perfect fit back then. And we learned a lot. We implemented a large scale dynamic routing between the transit gateway and the SD-WANs for our retail business. But when we started to implement the same greenfield for the health side of the business, we found Cloud WAN as a lot of benefits where it was a limitation with the transit gateway. So we adapted the Cloud WAN constructs to implement the health side. Uh, that's where we ended up with Cloud WAN.
Got it. Okay. So if we draw the scenario up a little bit, we will have the SD-WAN VPC.
Right.
We call it SD-WAN VPC. And you said that VPC was available in two AZs. So we were
Right.
using AZ1 and AZ2 for the sake
Right.
of simplicity. And inside you had an SD-WAN appliance. Let's call it SD-A1. And this is going to be our software-defined WAN appliance too. And then there was a public-facing interface. Let's call it ENI here.
Yep.
That was mapped to a public IP address, so elastic IP address out on the outside, right? And then up north, we're going to do a little bit big box for Cloud WAN for now to just keep it abstract. So we say this is Cloud WAN. And then the second interface, this in private ENI inside of the VPC of the SD-WAN appliances.
Right.
This is what you use to set up a connection to Cloud WAN.
Right. Right.
Got it.
Yeah. This. You want to switch back to the slide, or you want to continue the discussion over the whiteboard?
Whatever's easier. We can switch back to the slide and we can jump back to the whiteboard as we keep progressing. But I think this is what we have so far. we can probably talk about the tunnel-less connect, because I wonder if, like you mentioned that with Transit Gateway, we don't have the tunnel-less connect option, right? The way to connect SD-WAN appliances to Transit Gateway would be to use GRE tunnels, VPN
Yep.
tunnels. Yeah.
Yep. So in this slide, we'll talk about the integration between the SD-WAN and the Cloud WAN with the key innovation with our approach. Um, in a typical world, when we deploy any SD-WAN solutions, it can be any vendor. In our case, it is a FortiGate. It would be an active standby scenario. Like it's going to be same two availability zone, uh, and it will be talking to each other, which a HA interface. In that case, usually people used to do with two interfaces per VM or three interfaces per VM. One interface is dedicated to do the HA heartbeat between the VMs that span across multiple availability zones. So in that scenario, at any point of time, one VM will be actively handling the processors, routing protocols, and the elastic IP address is going to be attached to that particular VM, which is playing the active role. And the other standby VM is always going to be in a, as it is called, standby. And in the event of failover or any demanding situation, the roles between those active and standby will be switching to each other. And at that point, the elastic IP address will be switching from the active back then active VM to the new standby VM. So that's how the failover and failback process happened between that architecture. But in our case, both of the VMs will be actively handling the routing protocols because they are not talking to each other, both are standalone. We'll talk more about why it is being as a standalone in the upcoming slides. So the uniqueness in this is both of the VMs will have its own elastic IP address, which is bound towards internet, and both of the VMs will have an active BGP session towards the Cloud WAN CNE of that respective region.
Got it. So if we if we put it back on our diagram, so continue adding components here. So we're saying these elastic IP addresses here are unique. So we have elastic IP address 1 and elastic IP address 2.
Right.
And those two SD-WAN appliances are completely independent. There's
Right.
no kind of health
HA.
checking or syncing or HA between them.
Yep.
And I'm assuming that in the HA, because I know different vendors have different styles of a HA. Some of them would put two appliances in the same AZ and then move elastic network interfaces. And then some of them would have different AZs, but then move elastic IP addresses because you can't move ENIs in different AZs.
Right.
It sounds like in your scenario, that would be if you went with the HA from the vendor, you would require to have different EIPs and then kind of have the same EIP, but then move that EIP. So to rely on the vendor to move the elastic IP address, kind of if this appliance fails, move that elastic IP address to point to the other one.
Yep.
Right. Okay. And then, but instead, you treated them as independent appliances, and then you configured an attachment from Cloud WAN. So this is going to be an attachment.
That's a transport attachment.
Yep. And then on top of that attachment, you created BGP sessions from the private ENI to Cloud WAN.
Right. So and that transport attachment, we run two connect peer attachments, and each connect peer attachment is responsible for running an eBGP session between the respective VM and the CNE.
Got it. So that way, and then we don't have the SD-WAN cloud here, but I might just add it here as an additional blob that we'll hide in a second. But that was your SD-WAN deployment, and then your remote sites were down here, right? And then these, the SD-WAN mesh would connect to these appliances.
Mm-hmm.
Yeah, perfect. Okay. Okay. And then how did you, so I don't know if you want to jump into slides if you're going to go into that detail, but how did you then control active passive? What was the?
Yeah. So probably we can cover the Cloud WAN constructs like segments, segment sharing, and then we will come back to this thing that will be more sensible, I feel.
Perfect.
Yeah. So moving to the next slide, the integration strategy is what we discussed in the previous diagrams. So I'm going to skip this one. And the one of the key benefit of tunnelless approach here is, back in transit gateway, we are supposed to rely on GRE, where it is technically single flow 5-tuple connectivity. By nature, any point-to-point connectivity, single flow 5-tuple in AWS has a 5 gigabit of bandwidth limitation, whereas the GRE is technically a point-to-point. So that 5 gig bandwidth limitation is applicable for this GRE. On the other hand, Cloud WAN provides an option called tunnelless. Unlike GIE, the BGP sessions or the peer addresses will be the actual ENI IP address of the VM versus the IP address that's going to assign by the Cloud WAN when you introduce the Cloud WAN CIDR.
Got it. So ultimately, it's like a naked
Right.
BGP peering, right? Where
Yeah.
you don't have to put your traffic through a tunnel. So there's no tunnel limitation. So if your EC2 instance that you're using can support 25 gigs,
Mm-hmm.
you can get 25 gigs rather than
Exactly.
be limited by the tunnels. Nice. Yeah, that's
All
awesome.
right. Yep. Moving to the.
Did you have those? Just out of curiosity, did you have those kind of single flow limitations? Was 5 gigs something that you thought you might hit, or was it more about not having to worry about creating multiple tunnels to be able to support 25 gigs or
Yeah,
whatever?
both. For this health business, we don't expect that, but we need to always design for the worst case. So just report the maximum benefit of whatever the feature provides.
Understood. Yeah.
Right. Moving to the next slide. Um, uh, Branch connectivity, each branch who connects with the head end VMs in the SD-WAN VPC will have a dual internet circuit. So obviously there will be two underlay paths and obviously two overlay paths that will be having an IPsec tunnels from the branch to the head end. And from the head end VMs, the workload connectivity happens through the segments, which are the key behind the screen in the Cloud WAN world. And we will talk more about that in the upcoming whiteboarding. Can we switch, Adam?
Yeah, yeah. Let me jump to the whiteboard. So if I understand correctly, the next step is we have those BGP sessions from
Mm-hmm.
SD-WAN appliances.
Mm-hmm.
You mentioned we kind of abstracted it on my drawing, right?
Mm-hmm.
That the SD-WAN is just like a link to a cloud,
Yeah.
but you're saying there's two independent tunnels from each side. So
Mm-hmm.
each one of your sides, if we for a second draw it on top and then delete it, let me just get a different color. You had individual tunnels. So we're drawing it as a cloud, but ultimately this is what's happening, right? Every
Yeah.
single remote site has two independent tunnels that your SD-WAN solution can dynamically flip between depending on performance, availability.
Mm-hmm.
Got it. And then as we're
Right.
looking higher up into Cloud WAN, you mentioned there were additional things up here. You had different segments that you were using?
Yes. So for landing the transport attachment, we name it a segment SD-WAN.
Got it. So there was an SD-WAN segment.
Yep.
Let me see if I can create a proper rectangle here and make it look nice. Okay. And then ultimately, all of the routes that you were receiving from your SD-WAN appliances would appear in the segment, right?
Right.
All the BGP sessions would terminate ultimately as if they're in that SD-WAN segment, and the SD-WAN segment can see all of the remote sites.
Yes, you're right. And
Got it.
if it is, I know for now we kept as isolated segment. So uh, uh, the anything that is attaching to that SD-WAN segment will not get the or will not learn the routes of the other attachment.
Got it. So I'm going to put in brackets that it's isolated. Are there any other things attached to this?
Nope. So this segment is purely to terminate the transport attachment that carries the connect peer, so
Got it.
that all the routes from both the SD-WAN VMs will be landing or propagated to this segment.
Got it. And then how are your VPCs connecting in the scenario? Where's
Yep. So there are a couple of other segments in the same region called prod and non-prod.
okay. So I'm going to draw them as like side by side, so it's going to be easier to show. So we're assuming this is a single, and then let's do red for non-prod.
Yep.
So we're assuming this is a single region for now. So
Yep, for
easier to
now.
show
But I know
non-prod.
the segments can be stretched to multiple regions when we expand or scale in the future.
Got it.
Yep. From a segment sharing perspective, that is crucial to transact these routes to the other segments. The prod segment is being shared with the SD-WAN and vice versa.
Got it. And then I'm assuming the same thing for non-prod.
Right. And in
So
this
that's
case, prod and non-prod are also in isolated mode.
got it. So ultimately, pretty much all of the segments are going to be isolated. I'm going to put it on the
Right.
side, isolated. So ultimately, what we mean by isolated, right, is no matter how many VPCs you attach to each segment, they can't directly talk to one another.
Right.
And then the VPCs would be attached to each one of those segments. So if you had a few prod VPCs, they would
Right.
just
I know
be
right now we are in progress of having the transit gateway as well in the path, and it will be slowly migrated. But whatever you are drawing is going to be the future state
got
down
it,
the line. But right
got it.
now, transit gateway is actually attached to those respective segments.
So these are our VPCs. Got
Right.
it. So today you're saying you have a transit gateway that then connects to these segments, which you can totally do. It's a common pattern for migrating where initially your transit
Exactly.
gateway
Yep.
would be connected this way. So you guys are following exactly the migration process that we
Hmm.
recommend. And then but eventually the VPCs are going to land in each respective segment.
Respective segments.
Because you make it isolated, the VPCs can't use those segments to talk to one another, but they will
Right.
see all of the routes that are coming in from your SD-WAN estate.
Yep. By doing this, SD-WAN segment will learn the VPC siders of prod as well as non-prod, but both prod and non-prod cannot talk to each other.
Got it. And then because the SD-WAN segment is learning all the routes from non-prod and prod,
Hmm.
it can advertise those routes to your SD-WAN
Back to
appliances over the
exactly
BGP sessions, and therefore advertise them back down to your branch
branch.
sites.
Exactly.
Nice. Okay. Switch back to slides.
Yeah. And as a key differentiator between the traditional HA and the dual standalone, as you see, active standby means one VM doing nothing until something failure on the actual active VM, and whereas the key drawback with this active standby is though we run a custom virtual appliance on the EC2 instance that behaves as the SD-WAN head end, the Cloud WAN runs with the default BGP timers. So we are at the mercy of the default timers. Even though you enable some BFDs on the VMs, it's not going to be honored as Cloud WAN doesn't support BFD at this point. Maybe in the future, but I don't know. But because of this thing, when you do a planned maintenance, or if you do any patch upgrade on the SD-WAN VMs, or if something catastrophic happens, the AZ failure happens, and that triggers a failover from an active to standby, the the routing convergence time is something that depends on the default BGP timers. So the routes that are going to be withdrawn from the Cloud WAN routing table is going to take approximately 90 to 180 seconds, and that is going to disrupt the connectivity or any real-time sensitive connectivity that traverses between the SD-WAN VM and the Cloud WAN and the actual workload basically. So this is the key limitation that drove us to look for alternate solutions, and that's how we end up with standalone. I mean, dual standalone.
Got it. Yeah, there's some questions in the chat, and maybe we can bring up drawing as well. Let me
Yep.
just remove that, bring the drawing back up. There's a question from Tech First, that I think is relevant to like kind of going slightly a step backwards about like dealing with asymmetric routing.
Yep. I'm gonna talk about it.
Okay, yeah. So
Yeah.
okay, so we can so going back to what you mentioned. So the challenge, if I understand it correctly, with the active standby
Hmm.
is that we're not only relying on BGP. So BGP has to converge as well, but we're also making API calls to AWS to move an IP address or
Right.
move a network interface.
Hmm.
And then once you start stacking up all these changes, right, you first have to move that IP address, move an interface to a new appliance. That new appliance needs to establish a BGP session, then
Right.
needs to start converging and advertising everything from scratch. Whereas
Hmm.
with your model of active, well, two standalone, but still active passive,
Hmm.
allows you to like be faster. There's still BGP timers involved, but at least you're already exchanging all of the routing information. So if you happen to land on a different appliance, that has already a path to anywhere that you need to get to.
Yep. So, coming to that aspect, and that will probably answer the latest question as well. Uh, when you do dual standalone, both of the VMs is going to transact the routes. Potentially you can achieve ECMP, and the key thing that you need to do here in the SD-WAN appliances, you need to turn off the TCP SYN. Basically, you're turning off the statefulness feature on that VM, so that VM is going to purely act as a routing thing, not as an inspection thing. So there are some trade-offs, but we will talk, how we are achieving those trade-offs and compensating retaining the security posture in other ways. So you can adapt the ECMP as well. But even in that case, when one of the VM goes down for any reason, 50% of traffic is going to be impacted until the best route is going to switch to the other path, right? So even we don't want to do that. We took a different approach. Though both the VMs actively transact the routes, we used some BGP attributes to make one of the path always active, and the other path is always redundant. But the key differentiator is, by doing this, the cloud WAN will have an redundant route always installed, both the best route as well as the redundant route, right? Even in this case, when the active VM, let's be honest with this case. Even with this dual standalone, with one VM as a primary BGP path and the other VM as a secondary BGP path, when something catastrophic happens, the VM goes on maintenance or reboot on its own, not a planned maintenance. In that case, still we see a 30-second of the routing convergence. But on the other hand, when you do planned maintenance, you can gracefully move the traffic from one VM to other VM with without any disruption.
Got it.
Basically, the workload that we are dealing is like, kind of voice related applications. Like, if the connectivity is not maintained for so long, if the voice traffic is so sensitive and cannot tolerate those disruptions of even few seconds, the call is going to disconnect, and it
Got it.
which is a direct user impact.
Yes.
But when you gracefully move the traffic from one VM to other VM, as the routes are already installed in the cloud WAN, so the sensitive traffic is going to be retained. They don't even know the traffic has switched from one path to the other path.
Got it.
And once that is done, you can do whatever you want with the VM that you want to touch. You can do patch upgrade or even do a reboot and whatever we want to do.
Got it. So if we play it out on the drawing, and let's say this appliance here is your primary, and then this one is secondary.
Hmm.
Uh, you would modify your BGP attributes such that this path is the path used to any destination. So traffic kind of keeps going this way.
Right.
And then if there is a unplanned failure of this primary appliance, you're still at the mercy of, BGP timers, at least on the AWS side, because we don't do BFD with Cloud WAN today. You still have to wait for the BGP timers to converge such that return traffic starts using this path.
Right.
I guess on your end, on the SD-WAN side, right, each one of these sites has its own tunnel to each appliance. If this appliance fails, I'm assuming your failover would be a lot faster. So at least the traffic flowing into AWS can fail over faster. It's that the return path you might have to wait for in the scenario where the appliance fails.
Yes,
It's
which
an
is
unplanned
much
failure.
better than an active standby traditional way.
Yeah. And then if you're doing planning, you then update the metrics to make this guy the secondary, and then slowly traffic converges and moves to the other side, allowing you to do your maintenance with pretty much zero downtime.
Yep.
Cool.
But yeah, like you can ask now, there can be a question: what happens to the statefulness on the VM? Uh, there are other security components and inspection components in the path, as we know. Like if you establish an SD-WAN tunnel, always there is an supporting SD-WAN component at the branch as well. So where you have strict inspection rules. So here in SD-WAN VM, we terminate the tunnels with an IPsec. Obviously, we do the encryption plus encapsulation. The only trade-off that we are doing is the inspection at the head end.
Got it. So there's an appliance here. So this is a branch appliance. Appliance, and that is doing state. So here you're keeping state.
Yep.
Because you need to make sure you're allowing traffic and then remembering return traffic. On the head ends, you set it up so that there's no state.
Right.
Got it. So that way, it's pretty. It's possible to even traffic to come in one way, and if there's a path to come in the other way, it's still going to work. You don't have to worry about asymmetric routing.
Exactly.
But you're doing all of your inspection on the appliance. Yep.
Right. And also there are some inspection components within the AWS. After crossing the Cloud WAN, we have some third-party inspection VMs. That does another level of or layer of inspection before the traffic hits the actual workload.
Got it. So you can inspect inside of the AWS, but you're decoupling the routing from inspection. So, which is kind of the recommendation, right? If you can do that, avoid combining your routing with state, with anything that's state, nothing or firewalling, because then you'll end up with exactly the concerns about asymmetric routing. Whereas if you can decouple that, we have mechanisms inside of AWS allowing you to insert inspection, use nothing in a way where you don't have to worry about asymmetric routing anywhere.
Exactly.
Very cool. Cool. Gonna go back to.
Yeah, I mean that's all we spoke, about the BGP timers and the BGP attributes and the ECMP challenges and all those stuff. So yeah, we discussed all these points.
Yeah, got it. But it's interesting to the timing that you're seeing of the 30 seconds for the failover. It's kind of interesting to see. That is, I guess, that's also one of the good practices that for someone building on AWS to be able to avoid using during a failure scenario, doing a DR scenario, you want to avoid calling AWS APIs. Right. So if you can get away with like data plane level failover, which BGP is, instead of trying to call an API, move an IP address. That is because all of the AWS API calls, like API calls, are going to be asynchronous, so they take however long they take. There's no guarantee that something's going to complete in 5 seconds or a second, even if it does today. There's no guarantees that during a busy period it's not going to take longer. So I think it's a totally great idea to avoid that and decouple as well, like control plane.
There are two components in that. From a when it is in active standby scenario, one is AWS to detect the active and standby state of the VM, and that triggers the API to switch the elastic IP address from one VM to other VM. Plus the BGP timers between the VM and the Cloud WAN construct. So we cannot quantify the exact convergence time in this case, because it is a combination of both. Sometimes the API takes less than a couple of seconds. Sometimes it takes up to 10 seconds to switch the elastic IP address from one VM to the other VM.
Yeah, agreed. Cool.
Molly, just
Yeah.
one question. I'm just curious to find out, like, about you explain about this healthcare business, right? And you said it's very critical for an like patient, let's say, sitting at an older age person sitting at a home.
Mm-hmm.
He or she needs assistance, a quick assistance. So in that case, can you just for people to understand, can you just walk us through end-to-end path in terms of how the call goes, how the Cloud WAN handles it? Also, if you can just cover the active as how it fails over to provide the seamless connectivity without any interruption, so that we can understand the end-to-end flow, like how the call goes from that person's device all the way to the Best Buy's
It's
support
it,
people.
it's kind of a more voice-related architecture. I cannot go deep into that.
Okay.
I'm not a voice engineer, but from a high-level traffic flow perspective, the remote sites is where the agents sit. Who picks up the calls and chats of the end users. In this case, the senior citizens. So they pick up the call and they connect with various voice related applications, chats, and trunk SIP servers and multiple voice related things, right?
Mm-hmm.
So that traffic has to reach the SD-WAN head end via the internet path, which is the underlay, and the IPsec is the overlay. That way traffic lands into the head end, and once it reaches the head end, which actively serves the traffic based on the BGP attributes and metrics we set, and further the same preferred path is going to be followed for the connectivity with the cloud WAN. And once it reaches the SD-WAN segment,
Mm-hmm.
where the prod and non-prod VPC siders are learned onto the SD-WAN segment. That way, the traffic is further forwarded to the VPCs. And the return traffic is going to be the symmetric as long as we are not doing any graceful traffic switchover from one VM to the other VM.
Got it. Perfect. Thank you so much.
Yeah, I feel like voice is always the toughest, one of the toughest protocols to
Yeah.
Yeah,
transport because it's very sensitive, and immediately a human can detect something's off as soon
yeah.
as
Right.
you have issues. I don't know, Mandar and Jason, any other challenges you guys seen with the project on your end, or Molly, if you have any kind of big rocks or big challenges that you were hitting as you were going through this? What was the hardest part?
Hardest part was like uh, trying to understand the uh, the SD-WAN SLA things. Like I know, like I said, my peer engineer Joshua Hall, who discovered a lot of challenges with the BGP timers, number one, and number two with the IPSLA tracker. Basically, that determines which SD-WAN path from the branch to the head end is going to be preferred. That is the fundamental rule of SD-WAN, right? So we had to do some BGP maneuvers on the SD-WAN head-end VMs. Basically, the SLAs that we are polling via one VM should not be reachable via the other VM and vice versa. Otherwise, we will not be able to determine which VM we need to stick to on when the best path is available.
So the
So,
SLAs, when you say SLAs, maybe let me just pop up a diagram and we can kind of maybe zoom in a little bit closer. So uh, each one of the branches, we draw it as an abstract, or maybe we draw specifically these tunnels. So each branch would have tunnels to the different VMs.
right.
Are these going on different paths, or do you have different internet providers as well for
Yep,
extra resilient?
I think each remote site will have dual internet circuit.
Okay, so it's remote site. So these you would effectively lock the tunnels on different physical path and different providers.
Right.
Okay, and then you're using SD-WAN SLA feature to monitor these paths and
Right.
make sure that the remote side can flip on and use the path that's the most optimal.
Right. So in this case, we there are multiple ways to use the SLA endpoint. Either you can use the VM's own IP address, or you can use an IP address that resides outside of the VM. In this case, we picked a couple of Route 53 resolver endpoints.
Oh,
Basically that
interesting.
will keep responding on port 53, right? So we just wanted to decouple the SLA between the VMs and the SLA.
Got
So
it.
even though the VM goes down, the Route 53 resolvers, that's a managed endpoint. Again, it is less overhead for us. Route 53 resolver endpoints are not managed by us. I know AWS take care of that thing. And in this case, for redundancy purpose, we used two Route 53 resolver endpoints in each availability zone.
Right. So you deployed an endpoint in these AZs, and you
Yep.
were using the SLA was testing the path through each appliance to the endpoint.
Yep. One more in each availability zone. Can you do one more?
So there's two in each AZ, and then
Yep.
you're testing to those.
Right. So the important thing in this ENI is the Route 53 resolvers of AZ1 is not reachable via AZ2 tunnel, vice versa.
Got it. So you made it so that you're kind of hitting the endpoints only. You have a target only in that AZ
Yep.
that you're testing to. Okay. And it's independent from just the EC2 instance. It's a managed service, so its
Yep.
availability is going to be high.
Exactly.
Interesting. And it's an interesting, I guess that's an interesting idea for, because you had to use the endpoints and there's a cost associated with the endpoints hourly, right? So I wonder if that's a product feature request that we might want to take on and think about something where we could provide an endpoint that that we could respond to specifically for that use case. It's an interesting requirement.
Yeah, I mean, either you have to use any endpoint that responds for any TCP thing, or it has to respond for an ICMP. But here we opted this Route 53 because we don't need to put. Basically, when you spin up an ENI, until we associate that ENI with any component, it will not respond, even for ICMP. But Route 53 is by default, it is managed and purposely built to respond for port number 53. So that
Yeah,
way we took an advantage of that one.
very interesting. Yeah, that's a creative way to use another service for like a health check endpoint.
Yep.
And then are you so depending on the latency, would you have scenarios where actually even though SD-WAN appliance one is healthy, you would still, let me just get a drawing board. So say this one is healthy, but you detect that the path is latency is increasing here.
Hmm.
So you would flip and start using this one because you don't have state. This would still work, right?
Yep.
Is that something that you're actually doing as well?
Yep. Exactly.
Nice. Okay, that's excellent.
And no sessions are synchronizing between these VMs, right? It doesn't matter. No state, no inspection.
Awesome. Okay. Yeah, very cool. All right.
Any new questions?
I don't see any questions in the chat. I don't know, Jason, Mandar, any questions, comments from you guys?
Yeah,
That
Murli, I
was
just
to go ahead.
Yeah, Millie. I mean, we've been working on this for some time, and I kind of have a little bit of insight on, what you're doing on the retail business too. Maybe tell us what's next. So you've had this success, building this really unique architecture at Health. Understand that, there's some next steps you're going to do maybe on the retail side and connecting the stores. What does that look like?
Yeah, we have plans to switch our TGW based architecture to Cloud WAN down the line, but I don't have a timeline at this moment, but we are actively working on that path.
Right on.
Yeah, I mean, I was really curious to find out how the BGP failover actually pans out because the BGP timer is always a challenge, right? You have to wait until the session terminates after the timer is
Hmm.
expired. So that was something really curious to find out. Also gives a new perspective how you can fail over the traffic, not on a data plane, but on the API level. So that was really new thing that I discovered.
Sure.
Cool. I don't have any questions, any more questions. I think this was excellent. It was great to hear from you, Molly. Super engaging. Let's see if there's any questions from the chat. I see a question here from RT. Let's see. Yeah, it's a question. I think it's continued question more on the retail side about the architecture that you foresee for the SD-WAN headends and that redundancy, considering that you might have not as strict HR requirements with retail as you have with voice traffic. I would assume like that
Yeah,
probably you want to continue this with the same pattern because it seems like a solid
it
pattern
depends.
too.
Yeah, depends. Because the retail side is something different, and that can tolerate that kind of less than 30 seconds blip. But again, architecture, I would decouple this, day zero, day one, day two. Like day zero we spent a lot of time, and day one we took enormous amount of time to implement this. But when coming to supporting this infrastructure is little bit hard. It's not a easy thing to understand. If anyone comes into ops, right, they need to understand how this is working before they trigger a graceful traffic switch over. But when you deal with a minimum set of routes, for example, this is going to be less than 50 prefixes altogether, say for instance. But on the other side, when the scale is huge, when you deal with more than 8,000, 9,000 prefixes in our case, and that has to happen with a similar set of failover, then in that aspect, day two is going to be a nightmare when we want to do same thing.
Got it.
So it depends.
Yeah, there's a saying of this like 3 a.m. test, right? If you can wake up
Exactly.
an engineer in the morning at 3 a.m. and they can understand your architecture, that it's good enough to be production. But that sometimes depends on how good you document things. So that's
Exactly.
And then from a management point of view, I'm assuming you guys are using infrastructure as code and everything is automated with the deployment. You want to share a little bit about how
I know
that
I
looks
cannot
like?
talk more about this at this moment, but in this case, we are ClickOps in this particular architecture.
Okay. Cool. Okay. Let's see. Yeah, I see a question. I think we might have chatted a little bit about this, but any roadblocks, anything you encountered dealing with the healthcare compared to retail?
Any problems or roadblocks?
I guess the biggest difference is if you can share as well, but I'm assuming the voice one is probably the obvious one, right? But was there anything else?
Yeah, it totally depends on the sensitivity of the workload.
Right. So it sounds like for the healthcare, the sensitivity of the workloads is quite significant.
Exactly. And it not only healthcare, in my opinion, any voice related component is critical. Like say for instance, um, uh, uh, financial brokerage or any investment centers, like when someone is doing some huge dollar transaction, and if the call is disconnected, it's going to be a huge impact. So anything
Agreed.
with respect to voice is going to be critical and need seamless failover failback.
Okay. Well, I think with that, I don't see any additional questions. I think we can say goodbye. And thanks, Molly. Thanks a lot for jumping on. This was excellent. Thanks, Jason, Mandar. Thanks, everybody joining. We're going to have a session next week, so come and join us next week. But for now, thank you, everybody, and see you soon.
Thank you.
Thank you,
Appreciate it. Thanks
guys.
for having us. Thank you, Molly.
Thank you.